Alright, for this problem we're given a map to look at apparently. It says that Orlando is 178 millimeters due south of Niagara Falls, and Denver is 273 millimeters from Orlando, and Denver is also 235 millimeters from Niagara Falls, so a bunch of different distances here. And it asks us to find the angle at Niagara Falls. Now, keep in mind this is on a map, by the way. If you're sitting here going, well, it's not, there's no way it's only that's not, millimeters doesn't make sense here. Don't forget the on a map part. This isn't some weird macro miles or anything strange. This is saying that physically on a map we have this distance. And I only say that because when I first read the problem, I had that first thought of, wait, what? But here, we're just going to set up a triangle. It says Orlando is due south of Niagara Falls. So we have this like vertical piece here. Now let's pretend that's vertical. It says 178. So let's just use the numbers for now. We'll just drop the units at the end. So this is Orlando down here. That was due south of Niagara Falls. And then it said Denver is somewhere else. So we'll just kind of put Denver over here for now. And if geographically that's wrong, they should have given me more information. So here we go. We're going to just drop this in here. We have our three different locations. It says that Denver, let me refocus that just in case. It says that Denver is 273 away from Orlando, so that's down here. And it says that Denver is 235 away from Niagara Falls. And it wants the angle up here. So at this point, once you've got your sketch of your triangle, you basically don't need any of the words anymore other than just verifying that that's what you're looking for. So we're going to find this theta, and we've already done a problem like this actually, so this will be pretty quick to work through. We see all three sides given. We know none of the angles at all. So we're going to go ahead and jump right into law of cosines because this is one of its two things that you want to work with, the side-side-side scenario. So we knew, or at least saw earlier, that we have cosine inverse of the side opposite the angle squared, so 273 squared, minus the square of the other two sides. And again, this is really nice when they've given us everything that we need. On the bottom, we always have -2 times, and then 235, which is our side here, and the 178 from the back end there. The last two of the top row always go in the bottom right here. A small disclaimer, other people often will use a slightly different version of this formula. I just like this one because it derives very naturally from the initial law of cosines formula. But they'll sometimes factor out negatives and change up the way it looks a little bit. But at this point, aside from all my rambling, we really are just done with the problem. We just have to go to the calculator, always check in that mode, make sure we're in degree mode. And I can just go in and very quickly just verify some values. We have 273 squared minus 235 squared. And don't be thrown off by how large the numbers are in this problem. It really doesn't matter so much because they're large on the bottom as well, which means as a decimal, this probably isn't all that crazy. Now I did it this time using the parentheses in the bottom just to show that that's okay. And so here we go. We get about 81.5 degrees if you want to go that route. I'm just going to say about 81 degrees realistically speaking. I just like my whole number degree measurements. So I'm getting about 81 degrees. And you'd want to ask yourself whether that's reasonable or not. All these values are pretty decently sized. So my assumption is probably actually an acute triangle. None of the sides seem to be largely dominant. But this side is the largest of the sides. So I do expect that if it's an acute triangle, that angle is likely to be is the biggest angle. It's likely to be a larger value. And we see here 81 is pretty close to a right angle. So that's pretty reasonable. It's not a guaranteed way to verify your answer. It's not a perfect way to verify it, but it is a way to kind of make some sense of it. So I feel pretty confident in our answer here, and that's where we'll call it.